This example is again an open related rate question, is in the sense that we're not asking for a specific value, and it is what we call the heart attack problem. Basically, in this particular problem, a heart attack victim has been given a blood vessel dilation drug to lower the pressure against which the heart has to pump. For a short while after the drug is administered, the radii of the affected blood vessels will increase at 0.01 radiat per minute. Now, according to this French mathematician's law, and I did not take French, so I won't even try to pronounce his name. I won't even try. The volume is equal to a constant times the radius to the fourth power. Our question is, what percentage rate of increase can we expect in the blood flow over the next few minutes? So while we give this particular drug to try to create a larger vein to get the oxygen or the volume of blood to flow through, we're going to try to figure out what rate will the volume increase. Okay, so again, we have a rate given to us. They were fortunate enough to give us the formula that equates volume to the size of the radius. So, given the rate at which the radius is increasing, one radius length per minute, and again, different veins are different sizes, what is my volume? Well, I take the derivative of this with respect to time. I get 4kr cubed dr dt. Put in, for my volume, the rate at which it's changing. Leave my volume blank, that's what I'm looking for. Put in that value. And you can see what I get here is 0.4 kr to the fourth power. Now, we don't know the constant, we don't know the radius, but what's interesting about this is when we put that value in, I once again have kr to the fourth power. That is what volume is equal to. So all I did after I multiplied 4 times 0.01 to get 0.04 is I substitute out the kr to the fourth power, and this is what I now have. So what I can read this now as is the rate at which the volume is changing is 0.04 of your total volume, which would mean that our volume of the blood flow increases at a 4% value. That's what this drug is doing. It's a very complicated looking problem, but it actually turns out to be a very simple related rate based upon, given the rate of radius increase, the volume formula based upon the mathematician's law of how volume increases, little multiplication, substitution, and there's our answer.